Welcome to this lesson on the periodic table groups. We will focus on Group 1 alkali metals, Group 7 halogens, and Group 8 noble gases. By the end, you should understand their key properties, trends, and exam-style predictions. The periodic table is divided into groups shown as vertical columns. Each group contains elements with similar chemical behavior because they have the same number of outer electrons. This is important for predicting trends and properties. For a deeper look into the periodic table, how to predict the group an element belongs to, its oxidation number using the electronic configuration, click the link at the top right corner. Group 1 elements are called the alkali metals. The most common ones are lithium, sodium, and potassium. They are relatively soft, meaning you can cut them with a knife, and they appear shiny when freshly cut. As you go down Group 1, the melting and boiling point decreases. Lithium has a higher melting point than sodium, and sodium has a higher melting point than potassium. Exam tip: remember, trends are tested often. Always state whether the property increases or decreases down the group. Another important trend is density. The alkali metals become denser as you go down the group. So lithium is the least dense, followed by sodium, then potassium. The most important trend is reactivity. Reactivity increases as you move down Group 1. Lithium reacts gently with water. When sodium reacts with water, it forms sodium hydroxide and hydrogen gas. The reaction is vigorous, producing fizzing hydrogen gas. Potassium reacts even more strongly, sometimes producing a lilac flame. This because the further the outer electron is from the nucleus, the easier it is lost. Now, let's look at Group 7, the halogens. These are non-metals that exist as diatomic molecules, meaning they go around in pairs. At room temperature, halogens appear differently. Fluorine is a pale yellow gas. Chlorine is a pale yellow-green gas. Bromine is a red-brown liquid. And iodine is a grey-black solid. Let's look at the density. Density increases as you go down Group 7. So chlorine is the least dense, bromine is denser, and iodine is the densest of the three. Unlike Group 1, Group 7 reactivity decreases down the group. Chlorine is the most reactive, bromine is less, and iodine is the least reactive. Exam tip: always compare halogens carefully. Students often mix up this trend with Group 1. Next, we will look at the displacement reaction of Group 7 elements. Displacement reactions are very important in exams. The key rule is simple: a more reactive halogen can push out or displace a less reactive one from its compound. This is because the more reactive halogen has a stronger ability to gain electrons. Let us see the first example. When chlorine is added to sodium bromide solution, a reaction takes place. The products are sodium chloride and bromine. You will see a brown color because bromine is released. Exam tip: always write the products clearly. Sodium stays with chlorine, and bromine is displaced. Now, consider fluorine, which is the most reactive halogen. If fluorine is added to sodium chloride solution, fluorine displaces chlorine. The products are sodium fluoride and chlorine gas. You will notice a yellow-green gas forming, which is chlorine. Exam tip: remember that fluorine can displace every other halogen, since it is the most reactive. Now, let us study Group 8, the noble gases. Examples include helium, neon, argon, krypton, and xenon. They are very unreactive because their outer electron shells are completely filled. They exist as single atoms, so we call them monatomic gases. As we move down group 8, the boiling and melting points increase. For example, helium has a very low boiling point, while xenon has a much higher boiling point. This is because the atoms become larger and the weak forces between them increase. Remember, if asked why noble gases are unreactive, always link it to their full outer shell. Let us look at an exam-style example. In question 1, aqueous chlorine reacts with aqueous potassium iodide. You are asked to complete the symbol equation for this reaction, identify the type of reaction and state the color of chlorine gas at room temperature and pressure. Question 2 is about reaction of group 1 element reaction with cold water. You are required to arrange the elements in order of reactivity starting from the most reactive. You can pause the video to give it a try. Here are the answers to the questions. Let's take a moment to test your understanding of what we've covered so far. Please choose the correct answers to the following questions. You can pause the video if you need more time and also re-watch to answer the questions. Thank you for learning with AceStudents. If you found this lesson helpful, be sure to check out our playlist for more videos. Every video includes evaluation questions to help you test your understanding. Our content is perfect for homeschooling, Google Classrooms, or private tutoring. Don't forget to subscribe and click the notification bell so you never miss a new science lesson.